Alright, so here we're going to look at a secant graph. And the secant graph is the opposite of a cosine graph. So to graph a secant, I would personally graph a cosine graph with the same attributes and then just do the opposite for the secant. So you notice that our maximum is 1. In this case, our minimum is 1 and it goes up, and on this side -1 is our maximum for the other side. So it's almost like the roles switch. So when our A value gets bigger, our amplitude gets bigger. So you can notice it goes up and down, and then it reflects if it's negative. Our C value moves it to the right and to the left. That's our phase shift. Shifts the graph to the left and to the right. Our D value is the vertical shift, so it moves it up and down. And the B value is our period. And again, our period is 2 pi because we are back with cosine. So everything goes with the 2 pi. So again, if it's at 2, it's cut in half. And if it's at 1/2, our period is doubled. So the same thing happens with a cosecant graph and the sine graph. It mimics the sine graph, but of course it's the opposite. Now if we look here, this one also has what are called asymptotes. So again, we cannot divide by 0. So whenever our x value is 0, like at x equals pi over 2, we have an asymptote because it would be 1 divided by 0. And we can't divide by 0, so we have an asymptote. We'd also add another asymptote at negative pi over 2, because again, that would be where we'd have -1 over 0, and that would give us no answer. So we have asymptotes. And the same goes with the cosecant. We would have asymptotes with the cosecant everywhere the y value is 0, because that coincides with the sine, or that matches up with sine. The secant matches up with cosine, so whenever x is 0, we get an asymptote, and the cosecant matches up with sine, so whenever y is 0, we have an asymptote.